Welcome. Tonight, we're looking at a growing crisis: light pollution and how it's squeezing astronomy. The images show a clear contrast between a pristine night sky and an orange, glow-filled cityscape, and the gauge hints at rising sky brightness. Over the next minutes, we'll explore what's lost when artificial light climbs into the sky and how we can push the stars back into view. This slide shows how sky brightness is accelerating faster than population growth, nearly doubling on a multi-year timescale. And that trend is no accident. More efficient but poorly shielded LEDs, expanding cities and rising satellite numbers are all driving rapid increases in sky glow, which in turn overwhelms professional observatories and even backyard telescopes, turning once dark places into unusable borders for astronomy. As background luminance rises, faint cosmic signals get swamped and telescope detectors saturate, forcing much longer exposures and reducing usable frames. That means surveys miss transient events, costly observation time is lost, and some facilities report discarding large fractions of frames. The net effect is a drop in signal-to-noise, longer mission times, and shrinking discovery potential across observational science. Street lighting and urban lamps leave spectral fingerprints that blend with starlight, creating a messy, contaminated spectrum. Untangling those blended signatures demands intensive post-processing and still leaves doubt, which undermines the precision needed for radial velocity planet searches and cosmological distance measurements. In short, spectral contamination turns clean stellar fingerprints into noisy data, eroding confidence in critical measurements. Satellite constellations introduce a new layer of threat to both optical and radio astronomy. Projections show a dramatic rise in low Earth orbit objects, causing streaks across wide-field images and corrupting time-domain surveys during twilight windows. On the radio side, powerful constellations can jam protected bands, threatening sensitive telescopes and microwave background research, so orbiting fleets are now a serious observational challenge. Wide-field surveys and amateur astronomers are especially vulnerable. Local sky glow and satellite streaks erase comets, supernovae and exoplanet signals, and routine astrophotography slides from contribution to impossibility. The comparison between past pristine skies and future compromised views is stark. Many discoveries and monitoring opportunities will be lost unless we change how we light our world and manage orbital brightness. Light at night also disrupts life on Earth. Nocturnal pollinators and migratory birds lose orientation under perpetual twilight. Food webs, fracture, and sea turtle hatchlings are misguided by artificial light, reducing survival. For humans, blue-rich LEDs can suppress circadian rhythms, increasing risk for metabolic and mood disorders. The same photons that erase galaxies from our view also erode living systems and human health. There's a real economic and environmental price to upward light. Billions of kilowatt-hours are wasted sending photons where they serve no purpose, burning fossil fuels and compounding carbon emissions that drive climate impacts. Cities shoulder financial burdens for illumination that often delivers little safety benefit once glare and trespass are accounted for, meaning better design could save money and emissions simultaneously. The good news is, practical solutions exist to restore dark skies. Simple measures like full cutoff fixtures and shielding, switching to warm 1800K amber LEDs with lower lumen outputs, and deploying motion sensors and adaptive curfews can cut sky glow dramatically. Those steps improve visibility, restore scientific value, save energy and money, and preserve public safety and urban ambience when implemented thoughtfully. Preserving the night sky is both practical and proven. Places like Flagstaff and the Canary Islands show that stringent lighting ordinances produce research-grade skies and vibrant communities. Scaling up requires extending codes globally, adopting UN-style guidelines for satellite reflectivity, and protecting radio-quiet zones, and treating dark skies as a shared cultural and scientific heritage worth safeguarding for future generations. Addressing this crisis needs coordinated effort across astronomers, citizens, industry, and policymakers. Individuals can adopt dark sky practices and demand satellite limits. Industry can fund next-gen mitigation technologies, and governments must enforce effective regulations. The window for action is narrow, so a united campaign now can preserve starlight and leave a functioning night sky for the next generation to explore. Here's a practical call to action you can start tonight. Audit your outdoor lights and identify unshielded glare. Share a photo of unshielded fixtures with the hashtag number #DarkSky to raise awareness, and contact local representatives to support shielding ordinances. Remember, every lumen redirected downward returns galaxies to view and hands the universe back to tomorrow's curious eyes.